Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today I have brought you a very interesting LeetCode problem, LeetCode 93, Restore IP Addresses. One of the favorites for FAANG companies as well as Salesforce for their interviews in last 1 month of coding interviews. So let's see what does this question say and how do we solve it. So this question basically gives you some integers in a string S. Okay. And you have to convert those integers into valid IP addresses. They cannot be invalid IP addresses. Now, how do you define those valid IP addresses? The question has provided. So you have exactly 4 numbers within that IP address separated by 3 dots. And all those 4 numbers should be between 0 to 255, both inclusive. Like they could be 0 or 255, but neither less than 0 nor greater than 255. And they can have a single 0, but they cannot have leading zeros. Also, the number you have been provided in the string, you cannot change or reorder it. So you cannot make 552 out of 255. You cannot reorder them. You have to keep the order of these numbers intact. You just have to position the dots and create a list or an array of all possible IP addresses. Now, when you look at this question at the first time, you would say that as a brute force, if I have to solve it, I can use backtracking. And that's exactly what I'm going to advise you use here, even though you can optimize the solution and code it using dynamic programming. But that is not something I would recommend for this solution, as well as that is not something the examiner would be looking forward to. So let's solve it using backtracking and see how we code it and what is the background behind this. Okay. So let's look at these examples first. So you have been provided 0.1.2.201. So it's a valid IP address because it's separated by 3 dots and it has 4 numbers distinctively. And even if it has zeros, they are not leading zeros. And another one, 192.168.1.1. Again, 4 distinct numbers. None of them have leading zeros and all are between 0 to 255. So they are valid IP addresses. Now let's look at this one. 0.011.255.245. So it is not a valid IP address because it has a leading 0 here. Similarly, this one, 192.168.1.312, it's not a valid IP address because it has 312 which is greater than 255. So it's not valid. Now 192.168.1.1, again it's not a valid IP address because it has a non-numeric character. Now let's look at example 1 here. So I've copied the string here and let's see how we are going to solve this. If you have the string 255, 255, 111, 35, you would think that let's place the dots randomly. So if you start placing the dots randomly, you can either place the first dot after 2, or you can place it after 25, or you can place it after 255. Can you place it after 2552? No, you can't, because then the number will become greater than 255. So you have only 3 options, either 2 or 25 or 255. So I suppose I place it after 2. If I place it after 2, then the next one, I can either place it after 5 or 55. I cannot place it after 552 because then again it is greater than 255. So say suppose I place it after 55. Then I can place it either after 2 or 25 or 255. Say suppose I place it after 255. Then I have a 5-digit number still remaining. So it's not a valid IP address because you can have only 4 numbers separated by 3 dots and they can have maximum of 3 characters. Otherwise, any of the number which has more characters will become greater than 250. And they cannot have leading zeros. That's the crux of your question here. And you have to return all possible IP addresses which are valid IP addresses, an array of them. So first example, as you can see, only 2 valid IP addresses were found, which are these. And the second example you have been given as 0000, and you cannot have leading zeros. So you can have them distinctively only. So you have 3 dots separating each of those zeros. Now the third example, 101023, again you cannot have leading zeros. So you can have 1. And then you cannot have 01 or 010 because then it means that you have a leading 0. So you can have only 0 there. And then you can have 10 or 1 or 0 like that. Okay. So that's how the pairs have been made. So I hope the question is clear to you. Also, you have been given that the length of S can be maximum 20. That is, it can have maximum of 20 characters. And it can be greater than 1 or less than 20. So if it says that it can have only maximum of 20 characters, what does this mean? Suppose every time you make a choice, you can have a maximum length of 3 characters in one number, right? And your maximum length for S is 20. But keep in mind, if your length of the string is more than 12, anytime you can experiment, add more than 12 characters to the string, and you have to separate them only by 3 dots, you will have numbers which would be greater than 255. So anytime you will not have a valid IP address if the length of the string is greater than 12. So that's the first base case you have to have. If the length of string is greater than 12 characters, at that time you can just return a blank array because you will not have any valid IP addresses. So if the length is between 1 to 12, then you will have valid IP addresses. But what with the worst time complexity? So the worst case time complexity could be you have 3 choices every time to make. Either 1 character or 2 character or 3 character. And you can go up to length 12. So if you have said 3 characters and you can go up to 12, so your height of the decision tree would be 4, right? So your time complexity in worst case scenario would be O or 3 raised to power 4. So that is it about the time complexity. Now let's start coding the question, and if you have any doubts, ask them in the comments. It's an easier question, I would say. You just need to understand the integrities of the question since the question has not been worded very well. So if you understand the question well and you know how to apply backtracking, it's an easier question. So let's code alongside me, and whenever you feel like, pause this video, code it yourself, and then check your question. Still, if you have doubts, ask them in the comments. So first of all, I'll initialize my result array, which I will be returning in the end. So I'm also writing return result so that I don't forget it later on. After that, I will check for my base case, which is if length of the string is greater than 12 characters. If it is greater than 12 characters, I don't have to do anything. I just have to run an empty array, which is result. Okay. Because then it is not possible that you will have any valid IP addresses, since you will have one number at least which will be greater than 255. Now I will define my nested backtrack function. I prefer to have nested function so that I don't have to pass all the variables defined outside the function like result, etc. Now what variables do I pass in the backtrack function? So I pointer, which I run across the string every time, right? So my starting pointer for the IP address number is I, and then dots to keep a track of how many dots I have positioned. So for now, I'm assuming that I will have 4 dots, 3 dots separating within the IP address, and 4th dot at the end of the string, which I can remove during my coding part. Why I'm keeping 4th dot? So that whenever I place the 4th dot, I should check if I have reached the end of the string, right? If I have placed the dot says 4 count, as soon as I've reached the end of the string, then I have gotten a valid IP address. So that, and also my current IP address so far. So these 3 would be the variables which I will pass in this function. And then my another base case for this function would be I will check if my dots count is equal to 4. That is, I have already put 4 dots. And I have reached the length of the string. That is, I have covered the entire string. So in that case, I also need to remove the last dot because it's not required, right? So in that case, I will append this IP address as it is valid to my result array, but I will have to remove the last dot. So to remove it, I will just do -1. That's what we do in Python. And I will do return because we don't need to go ahead in the loop if we have already found a valid IP address. Now my another base case would be if, say, suppose my number of dots is already greater than 4. That means that's not a valid IP address and I don't need to go further in the loop. So then also I don't need to append it to the result, but I can return. Now I will write my loop. My loop would be for j, where j is my end pointer of the number. So say suppose I make a number 2 or 25 or 255. So my I pointer would be the starting index, while my j pointer would be the end index of that number, after which a dot will come. So to construct the IP address, I will go along the loop, along the string with j pointer, the end pointer in range. So say suppose I have already found the first number is 2. So my I pointer would be here, which is first index. So I need to pass that is the starting index. And then my last index until which I can go in J is I plus 3, right? Because I can have either a 1 length string or 2 length number or 3 length number. I cannot have a 4 character length number because then it will be greater than 255. But you would say, suppose you are at 3. At that time, I plus 3 would be out of bounds. So you cannot go I plus 3 then. Otherwise, you will hit out of bounds, right? So to handle such a scenario, I will take a minimum. And minimum would be I plus 3 and length of string s, whatever is minimum, so that you don't hit your boundaries if you take I plus 3. And now I have to check if my that particular number is less than 256. If int starting from I ranging till j plus 1, in Python the last index is non-inclusive, that's why j plus 1, and check if it is less than 256. Is this condition enough? I also have to check for leading zeros. So to check for leading zeros, I will check either my number should be single length if it is a 0. That is, my starting pointer and end pointer should be same. If it is one length and it's 0, I don't care. It's a valid string. Or my s of I cannot be 0, because if the number has more than one characters and it has 0, then it's a leading 0, right? But you would say that 1, 0 can be a number, but it's not a leading 0. But in that case, my I pointer does not have 0. My I pointer has 1. My j pointer has 0. J is the last pointer in the number. So I will check as I is not equal to 0 if it has more than one characters. Or I is equal to j, that is you have only one character and could be 0. So this suffices my all the conditions for valid IP address. And what I will do in that case, I will call my backtrack function. And I have to pass the right variables here. So when you call the backtrack again, what variables will you pass? So you have to pass the starting index. And since you have already run your loop till j index, then your next index for starting your next number would be j plus 1, right? And your number of dots, since you have placed one dot now, your number of dots would be dots plus 1. And your current IP would be your prior IP plus the character which you already found, which is s of I to j plus 1. You don't need to convert it to integer now because you are just adding it to the string, and you need to also add your dot character. So now I just need to call the backtrack function. So when you call backtrack function for the first time, initially you are at 0th index and your number of dots is 0. You haven't placed any dots, right? And your current IP address would be an empty string. So you call the backtrack function for the first time, and then this loop runs and runs until it has reached the end of the string, or it has found that there is no valid IP address possible. And you finally return the result. All your IP addresses are appending to your result here. Once again, I will repeat, the time complexity would be O of 3 raised to power 4, where 4 is your maximum height, which can be there in worst case scenario. So now let's run this code. Accepted. Let me remove all these comments so that you can see it in one screen. It's easier that way, I understand that. Let's submit. So as you can see, our solution is doing really well here. If you have a better approach to solve this question, share it in the comments. I would love to learn from you. If you have any other question you want me to solve it, ask them in the comments. I would be taking it up next in my next video. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.